Hello again, Method students. In this video, we're going to go through a few examples of solving trigonometric equations, and that's from 6E of our textbook. So we'll get stuck into it. We're going to do a few examples in this video, but for each of them, we're going to try to sort of follow the same 4 steps generally, which is we start by finding the first quadrant angle, or sometimes we call it the base angle. Step 2 is to find the quadrants where our function is either positive or negative, depending on what's happening in the equation. So we're going to find the quadrants where our solutions actually exist. Step 3 is to find those 2 solutions sort of in the first cycle. And then the last step, as we'll see, is that we can add or subtract the period as many times as we need to find additional solutions. And how many additional solutions we can find depends entirely on the domain. So we always have to look for the domain in these questions. All right, so let's get stuck into the first example. And it says solve the equation cos of x equals root 3 on 2, where x is an element of 0 to 4 pi. Okay, so we don't worry too much about the domain to start with, but what we think of is, okay, if we've got cos of an angle equals root 3 on 2, what would that angle have to be? And so if you're not sure, best way to start is to sketch the triangle that has root 3 and 2 in it. Now if it's cos, then root 3 would be the adjacent side and 2 would be the hypotenuse. And so if this is our adjacent side, then our angle must be here. And we know from our knowledge of these sort of triangles that that angle then is pi on 6. Okay, so theta equals pi on 6. Sometimes I like to call this the base angle. Right, and it's kind of like our starting point. And in some questions, this might not even be one of our solutions, but it's just the one that we kind of find our other solutions from. So I'm going to call that the base angle. Step 2 is to find the quadrants where the given function is positive or negative. And in this equation, it's cos of x equals a positive value. So from our unit circle, we know that cos is positive in the first and fourth quadrant. So we're looking for values in the first and fourth quadrant to solve this equation. And step 3 is to actually find those solutions. So we've already got the first quadrant angle, that happened to be our base angle. So x equals pi on 6 from the first quadrant. The fourth quadrant, well, we know that the fourth quadrant angles can be written as 2 pi minus theta, and in this case theta is pi on 6. So 2 pi is really 12 pi on 6. And so when we think of it as 12 pi on 6 minus pi on 6, then our answer is just 11 pi over 6. So at this point we have 2 potential solutions. We've got x equals pi on 6 and x equals 11 pi on 6. At this stage you would now start to think about this domain of 0 to 4 pi. Now both of those solutions are inside the domain. If it helps you, you might rewrite that domain so it is 0 to 4 pi. But because of our solutions being over 6, we might actually want to rewrite this, or at least think of it, as 24 pi over 6. Just makes it a bit easier to compare. So pi on 6 and 11 pi on 6, they're both inside this domain, which is what we want. We need to find if there's any further solutions, because the way that circular functions work is if you start from x equals pi on 6 and then add 1 period or subtract 1 period, you keep coming back to the same value. So the further solutions will come from taking our 2 existing solutions, and the first one was pi on 6, and adding the period. Now the period of this graph, and I should have written that earlier, I might write it back here next to the domain. The period of our function, which is, remember, cos of x, the period is going to be 2 pi on n, and in this case it's just 2 pi on 1. So the period's 2 pi, or 12 pi on 6, because in this question, with our values all being over 6, that might be more helpful to think of. So our further solutions are pi on 6 plus the period. Right, so pi on 6 plus 12 on 6 gives us 13 pi on 6. We also get, I probably should rewrite that a little bit better. This should be x equals. And another solution when we take our fourth quadrant answer, 11 pi on 6, and also add the period. We get 23 pi on 6. Now, both of these two numbers are still just within our domain. Our domain went up to 4 pi, or 24 pi on 6. But you can just tell by inspection that if we were to add the period again to these values, if we added another 12 pi on 6, this would become 25 pi on 6, which is too big for the domain. This one would become 35 pi on 6, which is much too big for the domain. Likewise, we could have tried subtracting the period from our first two solutions, but if we had done that, so pi on 6 take away 12 pi on 6, we'd get a value that's less than 0, and that's again going to be outside the domain. Same with the 11 pi on 6 solution. If we did 11 pi on 6 take away the period here, we would have got a negative answer, which again is outside our domain. Now, as you can see from my bit of paper here, your working can get a little bit messy for these equations, so it's a really good idea at the end to write down your solutions really clearly for anyone who's marking your work. So our final answer, our solutions were pi on 6, 11 pi on 6, 13 pi on 6, and 23 pi on 6. I'm going to put a box around that to make that really clear. And there we go.